Okay, here we go with section 5.1. Let's start off with this. The use of degrees for measuring angles is completely arbitrary. It was basically come up with as a coincidence of the fact that it takes 365, hence about 360 days for for 1 year to occur. Early civilizations linked on this as one cycle, so they broke it up into 360 parts, and bammo, you have this completely arbitrary way of breaking up one rotation or one circle. So you have a circle, you have 360 degrees. Well, that would mean from here to here would be 90. And then if you continued from 90 on, would be 180, and so forth and so on. And we'll look at that a little more in depthly in a moment. But suffice to say, the most important thing I could tell you is degrees are man-made. There is an angle measure that we'll get to at the end of this unit that is not man-made, that is as fundamental to the concept of circle as you can get, and would be the same no matter where you are in the universe. But for now, just keep in mind that degrees are completely man-made. There's other systems by which they break them up into 100 parts all the way around, and so forth and so on. I think they're called gradients, but for now, 0 to 360, one full rotation, 180 is a half rotation, and so forth, and we'll look at that. A bit of a review, if you recall, acute angles are angles, let's set up a tool here that makes sense. Boom. Alright, this should work. Okay, so acute angles, of course, would be ones that are less than 90 degrees. So theta. Now theta is the equivalent of x when it comes to angles. It's the unknown. So when theta is less than 90 degrees, we have an acute angle. Of course, if theta is exactly equal to 90 degrees, then we draw a little box in the corner to indicate that we know it's 90, and that's called a right angle. Obtuse angles, angles that are bigger than 90 but less than 180. So when theta is bigger than 90 but less than 180. And straight angles are, and we'll do these down here, a straight angle is simply, and I'll do it in two parts, but simply a straight line. And that, of course, means that theta is equal to 180 degrees. So, using the fact that this angle and this angle add up to 90 degrees, we can set up an equation and solve this fairly simply. 90 equals 5x plus 4 plus 5x plus 6. So 90 equals 10x plus 10. I'm going to divide everything by 10, so 9 equals x plus 1. And subtract 1, so 8. I believe x is going to be 8. Now, careful, that's not necessarily our answer. They want, for example, here, this happens a lot, they said find the measure of each angle. So this is x, but that's not the measure of each angle. So the angles would be, let's see, 5 times 8 plus 4 would be one angle, that would be 44 degrees. And the other angle would be 5 times 8 plus 6, which would be 46 degrees, which do in fact add up to 90 degrees. So careful you answer the question. Here, similar problem. We're going to have these two adding up to 180 because they form a straight line. So I'm going to have negative 3x plus a negative 15x, or just minus 15x, equals 180. Let's see, that's going to be negative 18x equals 180. Divide by negative 18. X is going to be negative 10. And then I'm going to plug that in because they're asking me for the measure of the angles. So that's going to be negative 3 times negative 10. It's a 30 degree angle. And negative 15 times negative 10, which just going to be a 150 degree angle. And sure enough, they do add up to 180 degrees, like we hoped. Now, as if degrees were not man-made and therefore annoying enough, then they go ahead and do this. So most of the time for me when I'm working with angles, I'm going to write something like 27.65 degrees, or let's do a little simpler example, 27.5 degrees. So 27 and a half of a degree. In many applications, that's fine. That's how your calculator is going to accept angles that are in degrees as a decimal. Okay. But there's another way to look at this part of an angle, or part of a degree, I should say. This represents 1 degree. I know it is much bigger than 1 degree, but I can't. If I draw 1 degree, you won't see it. So we'll look at this as represents 1 degree. If that were 1 degree, a minute, try not to, there's a kind of a vague association with the time minute thing, but just a minute is defined as if you took that degree and broke it up into 60 pieces, one of those would be a minute. So 1 minute, the little dash represents, a single dash represents minute, equals 1/60th of a degree. Then, if you took each of those minutes, so now this represents 1 minute, all right? So it's a tiny, tiny, tiny piece of a degree. And you split that up into 60 pieces as well. So now we have each one of these broken up into 60 pieces. That is defined as 1 second. So one of those is a second. One of these would be 1 minute. So 1 second is equal to 1/60th of a minute, which means, and this is going to be important later, it is 1/3600th of a degree. Yeah, I know, I get it. But we'll go through a few of these. It's not a huge emphasis on the test, although there are 1 or 2 that involve this. So we'll make sure we know how to do it. Okay. So working with them is a little strange because once you get more than, say, 60 minutes, this is 49 minutes, but if we add these and that comes out to be more, then we got to start, rearranging things. Although in this problem, kind of a lame example because it's not that hard at all. We're going to add I don't think we need the plus there. We're going to take 64 degrees 10 minutes and add it to 50 degrees 49 minutes. And I got 59 minutes and I have 114 degrees. Now, in this case, we're done. It's kind of a lame example because what we really want to be interested in, what if, I'll make up a new problem here. So what if I had 64 degrees and 15 minutes added to 50 degrees 49 minutes? Then what would happen? Well, I'd have 64, right? And then I'd have, is that right? 64, yep. And then I'd have the same 114 over here. But what I would want to point out to you is that here we have more than 60 minutes, which means we have 1 whole degree. So since 1 degree is equal to 60 minutes, I'm going to take 60 minutes out of this and make that into 1 degree over here. So that would be 115 degrees and just 4 minutes left over. Sorry, minutes, not seconds. There we go. Minutes. Alright, then even more fun is subtracting because now I have 53 degrees 30 minutes minus 35 degrees 42 minutes. But the issue, of course, is the whole borrowing thing. We don't have, you can't take 42 away from 30 in this situation, no negatives, so we have to borrow. So we're going to take a degree off of this. We're going to go, boom, make this 52 degrees. But do not add a 1 to this, because you were adding 1 degree, which is 60 minutes. So you borrowed 1 degree, but you have to look at it as 60 minutes. So 60 minutes is what we're going to add to the 30 to produce 90 minutes. Now I can subtract. So 42 from 90, let's see, have it up be 45, but we're short 3, 4, 5, 6, 7, 48, 48, I believe. Yep. So we're going to have 48 minutes, and then 35 from 52. See, 5 from 12 is 7, I believe. Yep, that's right. And then 3 from, we got to borrow, so 3 from 4 is 1, so 17 degrees, 48 minutes. It's arithmetic, so check me. If I'm wrong, you'll have to forgive me. Alright, so we have a lot of borrowing to go on here. When you run across this one on the homework, so we'll do, instead of looking at 90 degrees, I want to look at that as 89 minutes, degrees. Whew, I got this. And then we're going to make it, borrow that 1 degree, make that 90 minutes. But I still need seconds. So I'm going to have to actually borrow from the minutes as well. So I'm going to have 80. Did I say 90? Oh my goodness gracious. Whew. Man, I obviously did not get enough sleep last night. So you all caught that, right? We get 60 minutes, not 90. I don't know where the 90 came from. Now I'm going to borrow a minute from this to get 60 seconds, but of course that's going to reduce this down to 59. So what I'm going to really have now is 90 degrees. Oh my goodness gracious. Just 89 degrees, because that's what I had before. 59 minutes, and now 60 seconds. Now I'm in a position to use, it took me long enough, this number right here, this angle, which is the same as 90 degrees, and now it has all the minutes and seconds I need so that I can subtract. So we're going to start the problem. Is going to be 89 degrees, 59 minutes, 60 seconds, minus 44 degrees, 44 minutes, 42 seconds. 42 from 60, that's going to be 18. 44 from 59, that's going to be 5. That's going to be 15. Yep. And then 44 from 89 is going to be 45. So unless I've made a mistake out with my arithmetic, that should be my answer. Okay, so here's what you want to do when you're converting. When you convert into decimal degrees, which is, this is a useful thing to do, because on your calculator you're going to much prefer to use decimal degrees. There is a way on your calculator to enter degrees, minutes, and seconds. This is probably a better choice if they're mean and give you an angle like this. This is what you're going to do. Alright, so 85 on your calculator plus, well, minutes are 55 over 60. Every minute is a 60th of a degree, so we write this, plus 55 over 60, plus 24, now don't put it over 60, because if you recall, a second is 1/3600th of a degree, and we want everything in degrees. We don't care about minutes. If you put this into your calculator, you should get the correct answer. Let's see. So I'm going to do 80. Oh, come on. Oh, I know. Okay, we got this. We're good. Okay, let's try this now. So we're going to go 85 plus, let's use parentheses just to be sure. All the order of operations should be our friend here, right? We'll trust it. Plus 55 divided by 60 plus 24 divided by 3,600 equals. So the angle would come out to be, in decimal form, would come out to be 85.92333, so forth, degrees. And then I could put that in my calculator and just be happy and go on about my business. All right, going the other way. Here's the process. Less often that you'll have to do this, but we'll run through it. I got the 98 degrees part, right? Good, I got 98 degrees. It's the fraction that's an issue. So what we're going to do is take 0.4555 times 60, because that's how many minutes there are in a degree. So that's going to give me my number of minutes. All right, so we'll do that on the old calculator here. So we're going to go, is it 0.455? So let's just let's see if I can do this. Oh, Jehoshaphat's doing it again. 0.4555 times 60 equals. So that gives me 27.33. That's my number of, when I say that, let's point at it, ready? This is the number of minutes. Right here, 27. So I got 27 minutes, but now I need seconds. So I look at this decimal. So that's why I'm going to write 0.33 times, let's see, we're going to do 60 again, because this is 60 seconds. Yes, because this 0.33 represents about a third, 0.33, of a minute, not of a degree. So that's why we want to use the 60 here. So we're going to go 0.33, about a third of 60 would be 20, I believe. So that would be 20 minutes. So just take the decimal part, multiply it by 60 until you get all three parts. All right, a little more importantly, angles on a coordinate system. Some things to keep in mind. First of all, we'll use the green. Angles are measured as a rotation of an arrow or a ray. So if I, got two of them there, hold on. There we go. So I have this green line called a ray. It's going to start there. So we call that the well, we just call it the origin. Well, what side they call that? Doesn't matter right now. What really matters is from there we are going to rotate that green arrow. And so, for example, if I rotate it from here to say here, then that would represent this angle from here to there. So that angle, for example, will be more than 90 degrees. Guessing, let's see, about 30, about 120 or something like that. And anything that rotates in that direction is going to have a positive value. And this right here, where it ends, is called the terminal side. See, because it started here and went to there. And we always start on the positive, whoops. We're always going to start on the positive x-axis and then rotate counterclockwise for positive. And then, if we start, hit this button, there we go. If we start here and we rotate downward, or clockwise, then what we have is a negative angle. So anything this, if it started here and went like this, even if it went all the way around to here, it would be a negative angle. So for example, this would be about negative 50 degrees or so, but this is a negative angle. Now, notice you could have angles that are, in this method, more than 360 degrees, because if it was a 360 degree angle, for example, would simply be starting here and going all the way around back to there. If I wanted, let's say, 450 degrees, that would be all the way around, 360, and then another 90 degrees. So when I see that, when I see that, I can think of it, looks like a 90, but it might be a 450 degree angle. So keep that in mind. You have multiple rotations. And of course, a negative, just for the fun of it, a negative 450 degree angle would be all the way around this way and then another, so it would be down in here. Even the words, the spell check on Word doesn't understand this, doesn't know this word, but what it means is quadrantal, I don't know, angles. They're the axes. In other words, here's one of them, right there. Right, that would be either 0 degrees, I gotta stop doing that, either 0 degrees, or if we went all the way around, you could call it 360, and so forth. If you had this angle, that's of course 90 degrees. This would be 180. Right, from here to here would be 180. And then the other one, the bottom negative y-axis, is going to be 270 degrees. Think of it as multiples of 9. 9, 18, 27. So we'll do this in blue. So from here all the way around to here is 270 degrees. Coterminal angles. So, mentioned this a little bit a couple slides ago. If you start here, and then you go around, let's draw another one, and let's say we take that and we go, the green one goes around to like, let's go to 200 degrees, right? So let's say that's 200, oops, I hit this button, there we go. Let's say that's 200 degrees. That's from here past the 180 mark by like 20 degrees. Okay, well, that is just one way to end up in that position. Let's come up with another way. So with a different arrow, so I'm going to make this next one some other color. Let's work on that now. Make this here, we'll make it purple, and the end will be an arrow, and we'll do the thickness there. Okay, so in this case, let's start with, let's have this purple one start here, but go all the way around, past 200, all the way back to here, but end up in the same spot. Hence the name, coterminal. They end up at the same terminal side. But the purple got there in a different route. It went all the way around and got back to there. So of course, in order to be coterminal then, it would have to be the 200 degrees plus one full revolution, 360. So that would be 560. So you're probably picking up that to be coterminal, you either have to add or subtract 360 degrees, one revolution. So for example, another coterminal one, we'll pick a different color. Let's see, we'll do this, boom. Okay, solid. So we could have started, ooh, that's not what I wanted at all, but we'll just use it. So we could have started with this one. This is not working. We're going to get rid of this guy. Go away. We're going to go here. And we're going to go here. Here. And do this right this time. Boom. Okay. Solid. And an arrow. So we're going to start with this pink line here. And we're going to go go negative. So for example, you could get around to there. So if I went from here to there, like so, well, what would that be? Well, we've got a couple ways you can figure it out, but once again, 360 comes into play because this would be 360 degrees, but you're going back this way, so I'm going to take the 200 degrees from 360. That will give me what's left over here, and that's the angle I moved. So if I take 200 and I subtract 360, and I get the negative 160 degrees, That's the pink angle. Negative 160 is also coterminal, but once again, still just added or subtracted 360. So to find coterminal angles, either add 360 or subtract 360, and you can get an infinite number of them. You add 360 3 or 4 times, that means you go around 3 or 4 times, then you go to your angle. So it's just a matter of adding or subtracting 360. Find the angle measure in degrees not equal to the given measure of the least positive angle that is coterminal with A. So positive, I don't want to go negative, so I'm not going to subtract 360. I need the next biggest positive angle. So that just means I'm going to take 244 plus 360. I'm going to get 4, 10, carry the 1, 5, 6, 604 degrees, unless I've done my arithmetic incorrectly. It's the next biggest positive angle that will be coterminal with that. Find the angle least positive measure. That is okay. Same deal, except now this is at 554, which is more than 360. So I can take away 360 from this and still have a positive number. So I'm going to do 3. That's 0 from 4 is 1. 6 from 15 is 9, and 3 from 4 is 1. So 194 degrees. Once again, unless I've done my arithmetic wrong, 194 degrees is the smallest positive angle that is the same as this. So if you're looking at this and you see it's more than 360, subtract 360, you'll still have a positive number, which is what they wanted. Alright, well here, that's a lot of times around. Basically what you're going to do is I'm just going to add 360 to this, which is going to be the equivalent of subtracting. So I'm going to go until I get to a value. Now, you could do multiples of 360. I could do like 10 times 360. I don't know if that would work. That'd be too big, right? 3,600. That's too big. So if we go somewhere, we'll play around with it. Let's try it. Let's go 7 times 360. Let's see what we get. So I'm going to go 7 times 360. 7. All right, we can do this one. 7 times 360. Okay, here we go. We're going to do this. I did the wrong thing. 7 times 360. I can use a calculator. 2,500. That's fine. I can still do one more. So I'm thinking 8 times 360. All right, so 8 times 360 is going to be 2,880 degrees. That is going to be almost there. So if I add that to here, I'm going to get, let's see, 0 from, it's going to end up subtracting because one's positive, one's negative. So 0 from 9 is 9. 8 from 12 is 4. 8 from 8 is 0. And okay, so that would be negative 49 degrees. We're almost there. I'd still have negative 49 left over if I combined this with it. So I got to go one more time to get the positive. So negative 49 plus another 360 will do it for me, which means we're going to have to subtract again. So it's going to be 311 degrees, I believe. Find the next 2 positive and 2 negative angles that are coterminal. So I'm going to take 270 plus 360, get 0, 13, get the 1, 5, 6. 630 is the next positive, and then the one after that would be 630 plus another 360, 0, 9, 990. And then the next 2 negative are going to be 270 minus 360, which is going to be 0, 7 from 16 is 9. And that should be 90 degrees, I believe, right? Yep. And then after that, I'm going to go 90 minus, should be negative 90, right? Yeah. Minus 360 again. Negative 90 minus 360. So here we're going to get 0, 15, greater than 1, negative 450, I believe.